Okay, children, now Unit 8, that is heat changes associated with chemical reaction. Now, let's test whether chemical changes take place during chemical reaction. Okay, let's test. Okay, we have taken a beaker now and we are taking some hydrochloric acid. That is dilute. Taking diluted HCl. And now we are going to put a piece of magnesium. But here we are going to observe the heat change. So, what is the other instrument we have to take? Thermometer, isn't it? So, let's keep a thermometer here. This is my thermometer. Okay. Now, the initial temperature is indicate up to this. This is magnesium about 2 cm. Magnesium piece. Magnesium. Okay, now we are going to drop that into this. Now it is reacting. Yeah. Gas bubbles emerge. Magnesium dissolves. Gas bubbles form. Okay. Now what has happened to the temperature? Now you see what has happened here. The magnesium is completely react with acid. Gas bubbles forms. So a chemical reaction has taken place here. And what is the other change you can observe here? Observe the thermometer. Now the temperature is 35 degrees. So what has happened here? Temperature increase. What conclusion you are making by this observation? From where the heat given to the thermometer? What is the cause for the heat? Chemical reaction is the cause. So, we can conclude that when a chemical reaction takes place, temperature change also occur. Then, during this reaction, what has happened to the heat? Is heat absorbed from the solution or heat given to the solution? Heat given to the solution. That's why the temperature of the solution has risen. So, we can show this. We can represent this reaction like this. Reactant, product. So a chemical reaction has take place. It can be represented using this equation. Is it correct now? Yeah. The matter only I have shown here. Isn't it? What are the matter? Okay. Now let's show this reaction in chemical formula. What were the reactant we used? Magnesium. Magnesium solid. So we used magnesium solid. We can represent like this. And acid. How was the acid? A diluted acid. So diluted HCl. Physical state of the HCl is aqueous. Now, it produces what? Magnesium chloride. That is in the aqueous. And gas bubbles are hydrogen. Physical state is gas. Now is it okay according to our observation? Think very carefully. Here before we are writing equation, chemical equations. So the chemical reaction. We have learned this much. Here we show only the matter part. But by observing this reaction, another part should be there. This is not a balance. There is an imbalance of energy. We have balanced the matter only. We have balanced the atoms only. Now we have to think advancedly because the temperature has increased. The reason for the increase of temperature is heat energy gained by the solution. From where the heat gained? The heat release. During the reaction. So, from where this heat coming? From where this heat, temperature, this is energy. Heat, energy. Energy release. Where was the energy before the reaction take place? It was in the left side. Now it went to the right side. It is released to the environment. It is released to the solution. So now it is balance. Energy. The energy also balance. So now we can write this. We can correct this equation. How? Energy. Product. Energy 2. This energy was in the left side before taking place the reaction. Okay. Now what are you thinking about the energy in the reactant and the product? The energy in the reactant is greater than the product or lesser than? It is sure it is greater. So this can be shown in a energy level diagram. The reactant has the high energy. So, what are the reactant? This is reactant. Now, product. When the reaction taking place, energy leaves. Energy given out. That is, I marking this arrowhead out. So, energy in the upper level falls down. Isn't it? So, this is the product. So, energy level is high in the reactant. Energy level is low in the product because this much of energy leaves out. Isn't it? So, this is the energy level diagram. The energy increasing is upward. This is energy level. These type of reactions are called exothermic reaction. Therm means heat. Heat exit. Isn't it? Here heat exit. This much of heat exits. Okay. So these type of reactions are called exothermic reactions. What is the observation in the exothermic reaction? Temperature increase. Temperature increase. Okay. Now, let's show this chemical reaction in the energy level diagram. Okay. What are the reactant? Mgs and HCl. Is it correct? No. I have to mention the physical state. Is it correct? No. There I have to mention will. Diluted is. The energy in the reactant is in a higher level. This level. Reactant. Now, the chemical reaction is taking place. Energy is leaving. So, when leaving the energy, it lost, the reactant lost the energy. So, it goes to the lower level. It goes down. So, this is the product. What is the product? MgCl2 aqueous and H2 gas. Energy leaving out. Now, we have understood what is exothermic reaction. Now, we are ready to write the definition for the exothermic reaction. Now let's see some other examples for these exothermic reactions. Okay children, now let's see some examples of exothermic reactions in our day-to-day life and the uses of the energy during the exothermic reaction. Now we are talking from where the energy came? By an exothermic energy. By an exothermic reaction taking place inside our cells, in the living cells. What is that? Yeah, that is respiration. Respiration means what? The glucose molecules subjected to combustion, it reacts with oxygen and gives energy. Energy in the glucose. Glucose is the reactant. Glucose is the energy pack. Glucose is the resource of energy. It gives us to do our work. It's a very good example, isn't it? Okay. Now, not only this, that is, I explained was respiration. We cannot see that. We are not seeing the burning of glucose. But this combustion is fuels burning with reacting oxygen and give out energy is used. We burn firewood, we gain heat and we cook our food. We burn petrol, diesel, kerosene oil. However, the fuels burn and give out energy, so we can run our vehicles. We can make to work our machines. All these are due to the reaction of combustion, isn't it? So shortly, we can mention that combustion. It means whatever a fuel, glucose, firewood, petrol, whatever it is a fuel, energy base, and oxygen. Some products. Chemical products and supply energy. Now write the day-to-day examples. I give the first for my breath and respiration, cellular respiration. You know the chemical formula of cellular respiration? whatever, not only the petrol we are burning, fuel. And move the vehicles. Reaction metal and acid. Acid base neutralization. Acid base neutralization, also an exothermic reaction. We know we have done experiment how the sodium react with water. We are instructed use a small piece of sodium. Why? It is an exothermic reaction. It exceeds a lot of energy. Sometimes it bursts highly and cause accident. So we are instructed to use small piece of sodium. So that is sodium react with sodium, calcium or potassium. Sodium, calcium or potassium. Highly reactive metals react with water. So if we have known about the exothermic reaction, we can be careful when doing the. So awareness of the exothermic reaction is important to avoid the accident caused during the chemical practicals. What are the other? At home, in the building constructions, we prepare slate lime. That is calcium oxide reacting with water. It exceeds a huge amount of heat. So, children should not be allowed to add lime with water. We have to be aware of children. They can add this with water. It makes high accidents. After this quicklime, add this water, that is called slake lime. Preparing slake lime is danger. If you want to draw the energy level diagram, you have to know the chemical reaction for the cellular respiration. C6, H12, O6. That is glucose and oxygen. CO2, H2O and energy. I marked it by E, energy. You will be asked in the question papers in future to draw the energy level diagram to show the exothermic reaction or the relevant reactions mentioned here. So you have to know the chemical reactions too. This burning of petroleum fuels often occur in the test paper. When I am discussing the papers, I discuss all these parts. Okay. Reacting metal with acid, we have done for the example earlier. Acid base neutralization, we know we have done this. This one also we have done. Quicklime, I write it here. Quicklime, CaO, calcium oxide, and water. This is in solid state, this is liquid state. It gives calcium hydroxide. Is it okay now? No. This is only the chemical reaction. We are not solving the exothermic reaction. If it is an exothermic reaction, there must be the energy. So it gives out a lot of energy, heat energy. Okay. So whatever the questions, you can score the high marks, I think. Okay, now let's see